Thank you for the invitation to this forum. I have now the mission of the last mile as the last presentation. Some of the founder and CEO of Tonomia. Tonomia, the name actually is generated by AI, which means autonomy, but also in Arabic it means Tanmiya. This is a Tanmiya al-Mustadama. So this is actually the spirit behind this word. So what I want to speak today, we heard a lot this morning about big data centers, about the edge computing. What I'm going to present you is really the best of the two worlds, the best of the big data centers combined with the best of the edge computing. So why distributed AI factories? I think you all know the AI factories. This is the data center designed to make AI compute. And distributed, this is decentralized. Why do we need to decentralize? Today, the AI, as it's done, it's very, very expensive. We see how much cost one subscription to ChatGPT. It's vulnerable if you have a big data center. Recently, the CEO of Belgian telecom company, he said, with one drone, you can put a complete country off. So the need really for distributed AI is mandatory. Of course, we know all the issue of the energy and the grid capacity. If you want to have 100 megawatt installation, it's extremely difficult to find the energy. But if you can distribute these 100 megawatt into small pieces across the country, there is a very high chance that you can access this power. And also, we have seen also most of these big data centers are using non-renewable energy. We have seen recently, for example, Google, for not naming them, they removed the CO2 target from their sustainability report because they know they can never, ever meet their CO2 target. At Tonomia, we believe that we need to take the data center closer to the users, closer to the energy, and ideally is to recover the heat from this installation. We all know that 85% of the electricity goes into heat. When you are in Europe, where you have to heat the homes. So if you place, today all our projects actually in Europe are placed in areas where we recover completely the heat from. So how Tonomia AI factories look like or work? So we developed what we call a TonoForge module. Actually, I'm coming from the car industry, and my last job at Ford, I was the overall hardware integrator on an electrical vehicle. And at that time, because we put a lot of compute in a car, and they said, how can we monetize this compute beyond just building the LLM models and autonomous driving? So we got that inspiration when I created my company. In lieu of having a car, I created something that has the compute and the distribution. So it's an all-in-one module. It has the batteries. You can control the energy, you can manage the cooling, and we have also the servers inside. So you need just really to plug it to the power and to the network to make it work. This is how it is distributed. So this is the map of Belgium. So we can distribute this anywhere in Belgium where you have a network, which actually we could find that there is we can be 40 kilometers away from an optic fiber. And all the installation we identified in Belgium, they can be feasible. So we can deploy it, and we work with a national telecom company who owns all the network across Belgium to interconnect our installation. So we'll show it to you later. It's joint work actually between Tonomia and the national telecom company. So how do we select a location? As I mentioned, the first criteria ideally is to have renewable energy. We can recover the heat, and the network is available. In terms of cost, we have achieved 5x cost in APEX comparing to the normal data center. Today, 1 megawatt, excluding GPUs, 1 megawatt for a normal data center cost between $10 to $15 million. We are at $2.5 million per megawatt. We can deploy, if the optic fiber is available in the area, we can deploy in 5 weeks. And we know data centers, they can go to up to 5 years. If you can play the video, the first video. So this is the installation, how it looks like, how is it deployed. You can see in the front the batteries and all the power conversion system. You can see here all the cooling. Here we have 2 servers of 64 GPUs each from MI355 from AMD. And you can see every server has its own chiller. And this can be deployed actually, built in a factory, deployed on a site, and then just connected to the grid. Thank you. So somebody asked me, oh, you are making this micro data center. How much tier they are? Are there tier 1, tier 2, tier 4? I said, if you consider tier, meaning that your site will be always on, so actually, if we consider all our sites deployed, we can call it we are tier infinite, because you can never ever have all your system is working. Today, when you launch a prompt, a ChatGPT prompt, for example, on one site, if it's not running, you have the batteries for a certain time, but immediately it can send your request to another installation. So actually, theoretically, you have to put the complete country off in order to get the system off. So what we do as well is, for example, for universities, for military applications, you can create within this network, you can create a local network just between the universities with their direct connections, private direct connections. You can have, for example, a defense ministry. They can connect multiple bases in the country with their own internal network without even going through internet. So this is extremely, it's a very high redundancy, and it's extremely resilient. Now how I did mention the 5x in terms of data center. This is actually a breakdown of the comparison. So you can see here the 3 major costs of the data center capex. You can see here, you have on the bottom, the power infrastructure. In a normal data center, you are around 10 million per megawatt. This is the cost per megawatt, $1 million per megawatt. And then you can see then the GPUs, 26 million. I used here the NVIDIA. And then the whole installation, the connections, etc., 4 million. So in total, it's 40 million per megawatt. And in the last CES, Jensen Huang mentioned actually a number of $50 million per megawatt. He mentioned the 50 billion for 1 gigawatt. With the Tonomia solution that we developed actually together with AMD and other partners, we dropped, you can see the infra to 2.5 million, the GPUs to 20 million, thanks to AMD, and then we dropped the installation to 2.5 because it's a plug-and-play installation. And if we take now, as I mentioned, 1 Tonoforge with 2 servers, so we can have 128 AMD MI35, 355, and we can have actually 128,000 users with our software partner and AMD. We could get actually 128,000 users out of one box. It's 0.3 megawatt, and without GPUs, we are at 800K. This means if you have your own GPUs, we are GPU agnostic as well. We can sell you this Tonoforge, and you can put your server in it, and you deploy as you are. In that case, we become just like a power unit supply. So the other application also, we got a lot of demand from US. We can have distributed, but for different reasons, for example, for training, where you need to have megawatts in one location, we can actually have all these Tonoforge deployed on the same site. And you can see here, for example, we can add a generator. In US, there is a lot of lines, a lot of areas where you have natural gas, for example, line, where you have optic fiber lines in the same area. So in that case, you have a generator. The generator will produce the electricity, and it powers the installation. And actually what you can do, there are some chemical techniques where you can use the heat of generator to make cold, like the absorption, and you can use the heat to cold the installation. Also, what we worked with our GPU suppliers is, for example, every 3 years, we can take the complete installation and replace it and sell that installation to emerging market like in Africa, Latin America, etc. Because after 3 years, we still have like 50% residual value from the installation, and we have 2 years return on investment. So it's extremely profitable in lieu of having, for example, because we came from the cars, when there is a new engine coming, you don't take your car to the dealer and say, yeah, replace me my engine. You just get a new car. And it's exactly the same here. Because the price of the complete container with 2 rack of GPUs, it's 7.5 million. So why do you need to replace just the GPU? So replace the complete system. So for us, it's good because every 3 years, we can renew our products, so the machine is running. And emerging market, if you go to Asia, somebody mentioned this morning, 4 billion people in the big south. This is a huge opportunity for them to recycle the installation. So you see here the comparison. If I take 100 megawatt installation, these numbers are in dollar in billions. These are big numbers. You can see the power only, you would need 1 billion with a classical installation. With our installation, it's 250 million. Now, if you do include the GPU, you would need 4 billion for such installation. With our solution with AMD, we can actually drop this to 2.5 million. These are very big number. We did present this the first time in CES this year, and we had huge attractions on all the consortium that are building big data centers in Texas, etc. And actually, we are going in a few weeks to present this project with all the builders of data centers in Texas. So if you can play the video, the second one. Just to see how it looks like. So you can imagine a big field in the desert. You can install a lot of solar panels, for example, because during the day, that's where you need a lot of cooling, for example. So you can use the solar panel for all the cooling part of it. And then you can put a big warehouse where you can pre-install for example, the chillers on the roof, and then you can bring them on the site. You can see here natural gas genset. And then you can see here, you deploy them with a truck, and then if it's not running, you can take it out, you can replace it, etc. So this is a typical, as I said, application you can do very quickly that you can deploy. You have much less construction work on the area. So it's very repetitive, and there's a lot of development going into this direction. You know, some of our competitors like Vertiv, Armada, Schneider, they are all getting into this type. But to our knowledge, for all the benchmarking we did, nobody's at our cost. So we spoke about the infrastructure. Then with our software platform team, we did a partner. We looked if we put the models now in our installation. These are open source models, so you can compare the cost on the different marketplace platforms like Open Routers or Together AI or Base 10. You can see here, if we start with GPT OSS, this is 120 billion parameter. The market price today, it's around 24 cents. This is in euros. We are at 12 cents in the marketplace, and we have 2 years return on investment. We still apply. So if somebody wants to buy our system and he wants to sell tokens in million, this is what he can do. With 2 years return on investment, he can be 40 to 80% cheaper than the marketplace. And you can see here Mistral, which is the biggest difference. We are at 40 cents versus 2 euros. So, as I mentioned, this is not Tonomia only work. So it's a partnership starting with AMD, with Mytech and Supermicro, who are our partners today for the servers. And then we work a lot with Belgian telecom company Proximus. This is obviously for Belgium, but we can use exactly the same approach for any country. And then we work a lot because you need a lot of security. These are $7 million products, so you need to secure it. So we selected Motorola Solutions because they are the only one, I would say, global partner. So they developed all the security. They developed all the security cameras, access system together, and they are integrated by the telecom company. And of course, we work with Open Innovation. Open Innovation was founded by the former leadership team from G42. So it was CTO and engineering team that created. They are one of the, let's say, the leader in the market because they are in the AI since 2017. And Tonomia, we are the full integrator. And the national telecom company asked us, why not using all those models and make us a chatbot application? Because a lot of companies, they want to have just the final use, which is a chatbot. So we worked to develop a chatbot with Open Innovation. And we are able, actually, today. They gave us ChatGPT and Perplexity as a target. So Open Innovation developed to us an application that the telecom company can offer at €5 per month, which has the same, it has actually more features than ChatGPT and Perplexity, even though the user experience is not exactly the same. But it's extremely promising because we are dividing by 5 the subscription. So this application is running at Tonomia. We don't use ChatGPT at Tonomia. We use this application. And it's within the telecom companies since 3 months for the test. Now, we are here in the Kingdom of Saudi Arabia. How can we apply this to Saudi Arabia to make the AI, we call it anywhere, for everyone here? If we look today, there's a chatbot subscription in Saudi Arabia. It's around 100 riyal. It's 99 or 100 riyal. It's around $20. At Tonomia, if we deploy our infrastructure here in Kesar, we can guarantee with our partners a 20 riyal per month subscription for the same functionality of the chatbot. That's again a 5x lower. Let's make this together. And one of the reasons actually I came here, I was invited by the EPIC Simi, thank you for that, is really to look for partners in order not only making this happen, but producing locally, using local product as maximum as possible, including servers, including chillers, and then enable all the development ecosystem here in Saudi Arabia. And we had already some contacts so that they can develop the applications to enable this. That's what I want to present to you. Thank you.